Hello everyone. Today I'm going to present my project report about AI-driven query processing and database automation. My name is Eren İmren. This project explores how artificial intelligence can make modern database faster and more autonomous. Let's start with the basic idea. Traditional databases use fixed human-made rules to process data queries. This worked well in the past, but today we have massive distributed networks and changing data workloads. Because of this, static rules are no longer enough. Our report looks at how machine learning and reinforcement learning are transforming databases. By using AI, modern database can learn from historical data and real-time feedback to optimize themselves automatically. Why do traditional systems struggle today? According to researchers like Gate, old databases rely on rule-based and cost-based optimizers. These systems work well in a static environment. When the system faces a real-time change, like sudden workload shift or network delays, traditional rules fail. Furthermore, for complex tests like cardinality estimation, traditional systems use basic histograms. These models depend heavily on human experience instead of real-time data, meaning they often miss the best execution plans for the complex queries. To solve these problems, AI-driven query processing introduces a dynamic approach. Zhu and other researchers report that AI can completely replace traditional cardinality estimation. They use deep neural networks to map queries directly to their actual size. For join order optimization, which is very complex, systems now use deep reinforcement learning. As Kirshan explained, this method acts like a smart agent that learns the best strategies through trial and error. Experiments show that AI, this is method can find optimal execution plan up to 10,000 times faster than traditional for large queries. Another major change is happening in the data access and indexing. Traditional databases use general-purpose tools like B-trees. However, Kraska introduced a revolutionary complex called learned index structure. He argues that B-trees is just a model that predicts where the data is located. By training a neural network to learn the exact distribution of the data, the system can find research much faster. These learned indexes are not only faster, but they are also up to order of magnitude smaller than traditional beaters, which saves massive space of memory. Now let's talk about database automation. Modern systems have hundreds of complex internal parameters, also called knobs. Finding the best configuration manually is almost impossible for humans. As Robert explained, automated tuning methods use black box optimization. This means the AI does not need to understand the internal code of the database. It simply tests different parameters and looks the best performance output. This automation allows the system to adjust dynamically in real time, improving the output and lowering response times without human help. Researchers have tested these theoretical ideas on real systems. For example, the BO system treats the existing database optimizer as a black box and provides smart things for every query. In this truth system, test by Gate showed that the reinforcement learning models reduced average query execution times from 300 milliseconds down to 200 milliseconds. At the same time, it reduced CPU usage to 55% and memory usage to 50%. This proves that AI models can successfully save hardware resources while increasing performance. However, integrating AI into a database is not perfect, and there are significant trade-offs. Fourth, Zhu pointed out that machine learning models can be unpredictable. Enterprise databases require absolute stability, but ML models can sometimes make unexpected errors when data changes suddenly. Second, Gate notes that training these AI models requires high computational power and resource consumption. Finally, as Karska mentions, updating data is a challenge because inserting new information might require retraining the entire model, which can be slow. In conclusion, integrating AI marks a major shift in database management, while traditional systems struggle with modern workloads. AI offers highly adaptive solutions for query processing and autonomous tuning. Important engineering challenges like training costs and model stability is still remaining. However, the future looks bright. Combining traditional stable optimizing method and flexible AI techniques will provide the perfect balance of performance and resource efficiency. Thank you for listening. Here are my main academic references used in this project, including studies by Gate, Karska, Christian Robert, and Zhu.